Okay, so we were doing problem A here, and what you need to do is you need to go through, and just like you would any other oxidation state, you need to total up your electrons, right? And so we've been told that all of these are going to be 18 electron ones, right? So they're all going to total to what? 18. Yeah. Now, when we're talking about the first row that can total up to 18, what is that going to be? Or what period? Yeah. It's going to be the first transition metal one, right? Okay. So this is going to be the first transition metal row for all the problems except for E on that exercise. Okay. Now, this one right here, we're trying to figure that metal out, right? Now, how many electrons are going to be in each of these ligand attachments typically? How many electrons are typically in a single bond? Yeah. And so these are all going to end up with 2 electrons in them unless you make multiple connections, right? i.e. ligand multiple times. That hapticity, right? Okay, and so we look at this one right here, and it can't be hydrogen neutral because that only has 1 electron, and we wouldn't be able to make the full connection, right? And so this has to be H minus. Okay. Now that actually gives you important information when you start looking at the charges, right? So that's the only way this could have a delocalized electron that it could make a ligand connection with, right? So it's H minus, it's going to give us 2 electrons towards this, okay? So we've accounted for 2 electrons out of the 18. We go over to the next one. These are CO. That can be carbon monoxide, right? That has a pi bond, and so that can have a pi bond overlap. Again, those are delocalized electrons, aren't they? Okay. It also has lone pairs on the oxygen, which it could do those overlaps as well. Those would be sigma overlaps, right? Doesn't matter for our case here. We don't care. All we care is that they're going to give us 2 electrons each, right? And they're going to not need a charge. Okay? And so they are not charged. They're neutral. They don't want to affect our overall charge here. All right, so total number of electrons we have accounted for so far. 2 times 5, right? 10, plus another 2 from the hydride. So that's 12 so far, isn't it? So we have to account for 6 more electrons. The only place that can come from is the metal, right? Okay, now there was one other important piece of information we gained from this right here. That has a negative charge. There is no charge up here. So we have to be neutral overall, don't we? So if we have a negative charge on the hydride, what has to have the positive charge then? The only thing that could, right? Which is the metal. And so the metal is going to be the metal having lost 1 electron. Okay? So we need to account for 6 electrons. And the valence that it's going to be is the 7 one, right? Because we had lost an electron from this. Can everybody see it okay? Yeah. So the M plus is what will have these 6 electrons.
You count the orbital?
Yeah, because remember, those are also going to be electrons that can fill in. And good way to look at this is the hapticity, of course, with the charges of the different ones, and you could have made your life easy by looking at this table, right? Because it tells you all the information you need. You don't even have to think. But do you need the table? No, not really. Okay. The only ones you might want the table for is the stuff down here. Those are a little bit more complex, make your life a little harder because they have higher hapticity, right? The low hapticity stuff, like general chemistry, organic chemistry at this level, you guys should just not even have any difficulty with like a hydride or a CH3, right? The only way those are working is because they have a lone pair on them, and that's because they have negative charges. Okay, this stuff you may have more difficulty with. I don't think benzene you'll have any difficulties with, but like these ones you might have some difficulties with because like this needs a negative charge there for it to actually have that hapticity, right? And so it has a -1 charge, but it takes a little bit of thinking it through. Okay, so what you want to remember is that all of these diagrams actually look something like this, right? And this right here would normally be blank when you write these out. And then if you don't know the metal, what you need to do is you need to fill this in until you have the 18 electrons, right? On your total here. Is that making sense? Okay, so that's actually what we're doing, if that helps you mentally, is we're actually filling this side in. Okay? Started off blank, we didn't know what it was. We needed 6 electrons, right? And it had to have a positive charge because the hydride had a negative charge in it. Okay? That making sense so far? Okay. Does anybody have any questions? Okay. So you all are going to do it for the next one. Huh. Weird. Respond. Okay. Did that answer your question, by the way? Yeah, so the s orbitals always include